Okay, and here we have the SQA 2015 National 5 Lifeskills Mathematics, Paper 2, Question 4. A seaplane flies from an airport on a bearing of 050 at a speed of 170 miles an hour for 36 minutes. It then turns onto a new bearing of 190 and then flies at the same speed for a further 1 hour, 12 minutes. Construct a scale drawing to illustrate the journey. Okay, the bearings aren't so difficult, they are given to you, but we need to get the distances. Okay, use a scale of 1 centimetre for 20 miles. So let's consider the first length of this journey. Distance is speed times time. The speed is 170 times, remember that's got to be as a decimal, and as you can see up here, I did 36 divided by 60 minutes in an hour, that's 0.6 of an hour. So the first distance is 170 times 0.6, which is 102 miles. And remember that 20 miles has to stand for 1 centimetre, so divide that by 20 to see how many centimetres it has to be. So that's to be 5.1 centimetres on the graph. Okay, so as you can see, a bearing of 050, you put your protractor there, and you have your 0 going north, and you have this coming off at 50 degrees there, and that has to be 5.1, so you put that in and you make that as close to 5.1 as you can. Okay, and that's it there, 050, 5.1. Now he then turned on to a new bearing. Now to do that you've actually got to draw a north-south line, and the bearing is 190, now there to there is 180. So you've got to put your protractor on this side of it now and add on another 10 degrees. Another 10 degrees there because it's 190. And you see the wee score there. So it's coming through, and as you can see I've not exactly gone through the score, but that's kind of close enough for what I'm doing anyway. There it is there, and we're still going to get the distance. He's going at 170 miles an hour again. Now he's going for 1 hour 12 minutes. Now 12 minutes is 12 over 60, that's 0.2, so that's 1.2 hours. So his distance is 170 times 1.2, 204. Divide that by the 20 miles for each centimetre, and it's to be 10.2 centimetres. So again, you go back to the graph, and that has to be as close as you can to 10.2, 180 down there. And that's where he ends up at. Okay, so that there is your answer to part A. On to part B. The seaplane continues at the same speed back to the airport. Use the scale drawing to determine the distance and bearing of the airport from the seaplane. Okay, you can see some writing there. How did I get it? Well, there we have it there. Again, it was about 7.2 centimetres. Okay, and the bearing, how did I get the bearing? Don't forget the bearing is that angle there, all the way around to there. What I decided to do was to get, put that there, and I worked out that smaller angle there. Okay, and that looks like about 18 degrees. This is about 18 degrees, so 360 take away 18 is 342. Okay, so when I did this earlier on, I measured 7.1, times it by 20, and you get 142 kilometres in reality, and the bearing was 342, as I said earlier on. Okay, some costings here. The seaplane burns fuel at 32 litres per hour. Aviation fuel costs £2, 4 pence a litre. Calculate the cost of the fuel for the complete journey. Okay, so we need to get the time for the last leg. Okay, now time is distance over speed. That's the 142 we got earlier on, and it's going at 170, 0.835 hours. Okay, times that, and that just gives you 50 minutes approximately. Okay. So total time for the journey is the 36 minutes of the first leg, plus the 1 hour 12 minutes for the second, plus the 50 minutes we've just got. That's 1 hour 98 minutes. Take away 60, 2 hours 38 minutes there. So take away 60 minutes from there to add on an hour to that, okay? Divide 38 by 60 and you get 2.633 hours, okay? Seaplane burns fuel at 32 litres per hour. So if he's used 2.633 hours of flight, times that by 32, he's used 84.3 litres of aviation fuel. Times that by the cost per litre, and you get £171.97 for the whole journey.